All right, chapter 3 deals with the rock cycle. A couple things about rocks and minerals, as you may have read in the chapter. Uh, Rocks need to have two things that have to exist. They have to be formed in nature, and they have to have one or more minerals. But for a mineral to be a mineral, it needs to have that formed in nature and be solid. But it also needs to have a crystal structure and a definite chemical makeup. I know that we talked in class about ice and water. That was an interesting thing because ice ended up being uh, uh, a mineral, but water would not. Now, where do we use rocks in our life? Everywhere. You can see right here the pyramids, artwork, roads, buildings. We have it everywhere in our life, and without rocks, we just don't have uh, the structures that we are so used to living with. Um, Three main types of rocks that we talked about were igneous, sedimentary, and metamorphic. Remember, igneous are volcanic. They're magma. They're coming from the inside of the earth. Sedimentary rocks, usually on the surface. Those are just pieces of rock stuck together. They're usually found near water. Metamorphic rocks. Well, those guys started off as either igneous or sedimentary or metamorphic, and if you added heat and pressure to it, they would end up changing from one substance to another, like a butterfly, a caterpillar to a butterfly. This rock cycle, every rock on our planet is somewhere in this process. Igneous rocks uh, can weather or break down. They can erode or get moved around. They get dropped off, deposited. They get buried and squeezed together, and then they become a sedimentary rock. Now, if you added heat and pressure to that, it would change. It would go through metamorphism and change into a metamorphic rock. If it gets pushed down really far deep, it'll melt, and then it'll become magma, and then it comes back to the surface or stays underground and turns solid, and then it becomes an igneous rock again. Now, that's just following the circle all the way around. Now, they can switch positions anytime you want. An igneous rock could get under heat and pressure and turn to metamorphic. Metamorphic rock could break down and become sedimentary. Um, so anywhere in that whole cycle, you could end up having a rock. Now, if you do go to the classroom.com and click on the animations, there was one here about the rock cycle if you needed to follow that, and I would suggest that you do that. Here was that song that we sang in class. I'll give her one more shot, but it goes to the tune of Row, Row, Row Your Boat. It's sedimentary rock has been formed in layers, often found near water sources, fossils from decayers. Then there's igneous rock here since Earth was born, molten lava cooled and hard, and that's how it's formed. These two types of rock can also be transformed with pressure, heat, and chemicals. Metamorphic they'll become. Uh, I know it's not a great song for me to sing, but it does say a lot about what each type of rock is. So look at the words, read them, sing them if you want. It's a great way to remember the three types of rocks and how they're formed. This was talking about just the rocks in our crust. 95% of all the rocks on our planet are metamorphic or igneous because they're inside the earth where the magma is and where the heat and pressure are. 5% are sedimentary. Those are just sitting usually on the top of the surface of the earth. Now, if you just looked at the rocks right at the top of the surface, 75% are sedimentary, 25% are metamorphic. The two types of igneous rocks we talked about were intrusive and extrusive igneous rocks. Intrusive rocks form when the magma cools inside the earth, extrusive when the magma forms on the outside, on the surface of the earth. Intrusive, I think of inside, both start with IN, so that's how I remember that. Here are some examples of intrusive rocks. A couple things about intrusive igneous rocks. They do form larger crystals because they cool inside the earth. And inside it's hot, so those higher temperatures means that it cools slower. If it cools slower, it just gives it more time for those crystals to grow larger. So intrusive igneous rocks tend to have larger crystals, where on the other side, extrusive rocks tend to have smaller crystals because they cool on the surface of the earth. Since it's cooler on the surface, they cool quicker. If they cool quicker, they don't have time for those crystals to grow, so the crystals are much smaller. We also classify them by the amount of silica in their crystal sizes. Sedimentary rocks are just small pieces of plants, animals, and rocks that come together and get cemented into layers. Here are the three ways that they can get formed, just particles being dropped off and layered upon layers. Plants and shells, when plants and animals die, they cover the ground, and they just become in layers and layers over millions of years. And coal and limestone are kind of an example of that. And then the last way was when minerals are dissolved and then they reform into something else. Rock salt is an example of that. Here are some ways that we can show that water and wind actually have an effect on how, excuse me, how the ground looks. Mud cracks. This one obviously looks like mud and it's cracking. This one right here, ripples. There was once water there, but it just evaporated and leaving the dirt behind, which ended up turning into rock over time. And then you got the last one, which is cross bedding. That is where they looks like the wind was, or the desert was actually moving at one point, and it just was going whichever way the wind was blowing. Metamorphic rocks, just like the pictures up here, caterpillar plus time in a cocoon equals a totally different substance, like a butterfly. Metamorphic rocks, igneous rock and sedimentary rocks, if you added heat right here and pressure right here, can change into another metamorphic, a different rock, a totally different. You can see it starts here and it ends up here, totally different looking rocks. And here's a pathway of one particular sedimentary rock, shale. You add heat and pressure to shale, it becomes slate. Slate, heat and pressure added to that becomes firelite. Firelite with heat and pressure becomes schist. And with schist, if you add heat and pressure to that, it becomes gneiss or gneiss. So that's just one pathway. Now, metamorphic rocks can happen over a large area, like in a mountain range, or if like magma comes up and it covers a whole large area, that can affect and change metamorphic rock. That heat and that pressure changes that rock into something else. It also can be in just a small area, like where the magma might just come up and not actually hit the surface, but it just gets this area around the magma and heats it and changes it into another type of rock. As that rock cools and gets squished together and goes under that heat and pressure, sometimes that metamorphic rock, the minerals inside can form in parallel wavy layers, known as a foliated type of setting. You can see here, you can see the bands that are kind of set up here, or it can be non-foliated, like over here. It looks like there's no layers or bands of minerals here. It just looks like they're kind of just thrown together haphazardly. But right here, you can see the bands. Now with the quiz here, what I'd like you to do is go through this and try to figure out if you can find the answers. Unfortunately, I can move it, but you can't. But we'll figure that one out in a little bit. But here, rock cycle and 3 questions dealing with this rock cycle. Where are the loose materials developing? That's what it's breaking down, and so forth. And here's another few questions on the rock cycle right here, and just 2 more on the rock cycle right there. And that's it. Chapter 3, if you went through this, you went through the slide presentation, you went through the reading of the book, I think you're going to be set for the test. So be sure you ask me questions along the way. I know we're going to be doing some work along the way, so good luck.